Understanding the volt-ampere or VA rating of a buck-boost transformer is crucial for proper application and sizing. The fundamental principles involve analyzing the voltage boost or buck and the current flowing through the load. Let's break down the calculations step by step. Firstly, the nameplate VA of a buck-boost transformer is determined by multiplying the voltage boost or buck, thus the voltage difference the transformer is adding or subtracting, by the output load amps. This value represents the apparent power the transformer is designed to handle. Secondly, to calculate the VA of the output load itself, you multiply the output voltage by the load amps. This gives you the total VA drawn by the load connected to the transformer's output. Thirdly, the buck-boost VA, which represents the portion of VA handled directly by the buck-boost action, is calculated by multiplying the voltage boosted or bucked, again the voltage difference, by the load amps. This calculation helps determine the VA stress on the buck-boost transformer itself. Let's illustrate with an example. Suppose a buck-boost transformer is used to boost a voltage by 22 volts and the output load draws 8 amps. The nameplate VA of the buck-boost transformer would be 22 volts multiplied by 8 amps, which equals 176 VA. This 176 VA represents the minimum VA rating the buck-boost transformer should have. Now, consider that the output voltage after the boost is 230 volts and the load still draws 8 amps. The VA of the output load would be 230 volts multiplied by 8 amps, which equals 1840 VA. This 1840 VA represents the total power being consumed by the load. The buck-boost VA, specifically the portion handled by the transformer to achieve the voltage boost, is again 22 volts multiplied by 8 amps, which equals 176 VA. This means the buck-boost transformer is only directly handling 176 VA of the total 1840 VA being used by the load. It's important to note that the buck-boost transformer doesn't handle the entire output load VA. It only handles the VA associated with the voltage difference it's either adding or subtracting. The rest of the VA comes directly from the source. Therefore, selecting a buck-boost transformer with an adequate VA rating is crucial to ensure it can handle the voltage transformation without being overloaded. Overloading a buck-boost transformer can lead to overheating, reduced lifespan, and potential failure. In summary, the calculations are as follows. Nameplate VA of the buck-boost transformer equals voltage boost or buck multiplied by the output load amps. VA of the output load equals output voltage multiplied by load amps. Buck-boost VA equals voltage boosted or bucked multiplied by the load amps. By understanding these calculations, you can correctly size and apply buck-boost transformers in various applications. It is also very important to understand your voltage, current, and power requirements and limitations to prevent damages from occurring to either the transformer, the loads, or the power source. Considering other factors is important, such as the inrush current of a load, which may require you to significantly upsize the transformer to handle the temporary current spike. The type of load, whether it is resistive, inductive, or capacitive, affects the transformer's performance and selection. For example, inductive loads like motors can draw significantly higher current during startup, requiring a transformer with a higher VA rating to handle the inrush current. The ambient temperature in which the transformer will operate is important. Higher ambient temperatures can reduce the transformer's ability to dissipate heat, potentially leading to overheating and reduced lifespan. If the transformer is to be installed in a high-temperature environment, it may be necessary to direct its VA rating or choose a transformer designed for higher temperatures. The altitude at which the transformer will operate is also a factor. At higher altitudes, the air is thinner, which reduces the transformer's ability to dissipate heat. This may also require directing the VA rating. Installation location of the transformer also should be taken into consideration. Ensure the transformer is installed in a well-ventilated area to allow for proper heat dissipation. Avoid installing transformers in confined spaces or near heat sources, as this can lead to overheating. If the transformer is to be installed outdoors, choose a model that is rated for outdoor use and is protected from the elements. Considering the efficiency of the buck-boost transformer is another important step in the selection process. The efficiency of a transformer is the ratio of output power to input power, expressed as a percentage. Higher efficiency transformers waste less energy and generate less heat, resulting in lower operating costs. Selecting a high-efficiency transformer can save energy and reduce the environmental impact. Finally, consider any applicable standards and regulations. Ensure the transformer meets relevant industry standards and regulations such as those set by organizations like Underwriters Laboratories or the International Electrotechnical Commission. Compliance with these standards ensures the transformer's safety and performance. Always consult with a qualified electrical engineer or electrician when selecting and installing buck-boost transformers to ensure proper sizing, installation, and compliance with all applicable codes and regulations. A buck-boost transformer can be used to correct voltage problems where the voltage supply is either too high or too low. For example, in a location where the voltage supply is consistently lower than the required voltage for the equipment, a buck-boost transformer can be used to boost the voltage to the correct level. Conversely, if the voltage supply is consistently higher than the required voltage, a buck-boost transformer can be used to buck the voltage down to the correct level. This is especially useful in older buildings or areas with inconsistent power grids, where voltage fluctuations are common. These transformers come in a variety of sizes and configurations, ranging from small, single-phase units for residential or light commercial use to large, three-phase units for industrial applications. The choice of transformer depends on the voltage correction needed, the load requirements, and the available input voltage. When selecting a buck-boost transformer, it's essential to consider the specific voltage requirements of the equipment being powered. Check the equipment's nameplate for the required voltage and the acceptable voltage range. The buck-boost transformer should be selected to provide the correct voltage within this range. It's also important to consider the transformer's capacity to handle the load. The transformer's VA rating should be equal to or greater than the total VA of the equipment being powered. This ensures that the transformer can handle the load without overheating or experiencing voltage drops. In addition to voltage correction, buck-boost transformers can also provide isolation between the input and output circuits. This isolation can help to protect sensitive electronic equipment from voltage spikes and other electrical disturbances. Isolation transformers are commonly used in medical equipment, industrial control systems, and other applications where electrical safety is critical. Understanding the wiring configurations of buck-boost transformers is essential for proper installation and operation. Buck-boost transformers can be wired in various configurations depending on the amount of voltage correction needed. Common wiring configurations include bucking, boosting, and isolating. In a bucking configuration, the transformer is wired to reduce the voltage. This is typically used when the input voltage is too high. In a boosting configuration, the transformer is wired to increase the voltage. This is typically used when the input voltage is too low. In an isolating configuration, the transformer is wired to provide isolation between the input and output circuits. This is typically used to protect sensitive electronic equipment from voltage spikes and other electrical disturbances. When wiring a buck-boost transformer, it's important to follow the manufacturer's instructions carefully. Incorrect wiring can damage the transformer or the equipment being powered. It's also important to use the correct wire size and to make sure all connections are tight. Buck-boost transformers are typically installed in electrical panels or enclosures. The transformer should be mounted securely and should be protected from moisture and other environmental factors. It's also important to provide adequate ventilation to prevent overheating. Regular maintenance is essential for ensuring the long-term reliability of buck-boost transformers. Maintenance tasks include inspecting the transformer for damage, cleaning the transformer, and testing the transformer's performance. The transformer should be inspected regularly for signs of damage such as cracks, leaks, or corrosion. Any damage should be repaired promptly. The transformer should be cleaned regularly to remove dust and dirt. Dust and dirt can accumulate on the transformer's windings and can cause overheating. The transformer's performance should be tested periodically to ensure that it's operating properly. Testing should include measuring the input and output voltage, as well as the transformer's VA rating. If the transformer's performance is not within specifications, it should be repaired or replaced. Buck-boost transformers are available from a variety of manufacturers. When selecting a transformer, it's important to choose a reputable manufacturer and to select a transformer that meets the specific needs of the application. Consider the manufacturer's warranty and service policies. A good warranty can protect you from unexpected repair costs. A transformer with higher impedance will limit the current flow during a short circuit, which can help to protect the transformer and the connected equipment from damage. The impedance of a transformer is expressed as a percentage of its VA rating. A transformer with a higher impedance will have a higher percentage impedance. Transformers are available in a variety of insulation classes. The insulation class of a transformer indicates the maximum temperature that the transformer's insulation can withstand without breaking down. Transformers with higher insulation classes can operate at higher temperatures. Select a transformer with an insulation class that is appropriate for the operating environment. Buck-boost transformers can be an essential component in many electrical systems, providing voltage correction, isolation, and protection. By understanding the principles of operation, selection, installation, and maintenance of buck-boost transformers, you can ensure that your electrical systems operate safely and efficiently.